Welcome to Unit 10, Lesson 6, Angle Measures and Segment Lengths. In this lesson, you'll be able to find the measure of angles and segments formed by secants, chords, and tangents. Let's review our angle measures. Can we find the measures of angle X and angle Y? We notice that X is a central angle because its vertex is here at the center of the circle. So the measure of angle X is just equal to the measure of its arc, 44 degrees. Now let's look at Y. Y is an inscribed angle. Its vertex is on the edge of the circle. So its measure is half of its intercepted arc. So half of 86 is going to be 43. What is a secant? A secant is a line that intersects a circle at 2 points here, A and B. This is a secant. It is different from a tangent. A tangent line touches a circle in 1 point. And it's also different from this, which is a chord. A chord has its endpoints on the circle. Now we're going to begin by looking at angles. There are angles formed inside a circle that are not central angles, and they're not inscribed angles. Let's take a look at these. So the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So here we have a circle, and there's two lines intersecting in that circle. And we're looking at angle 1 here. The measure of angle 1 is half the sum of the two arcs, both this arc and that arc. We write it, the measure of angle 1 equals 1/2 x plus y. We add together the two arcs, divide them in half. So let's say that arc X is 80 degrees, arc Y is 60 degrees. So the measure of angle 1 is 1/2 80 plus 60, or 1/2 140, which is 70 degrees. Now what's this other angle? We have angle 2 over here. What's the measure of angle 2? Well, the measure of angle 2 is exactly the same. Their vertical angle is the same two arcs that were intersected. You could do all that work again, or you can just say they're vertical angles. They have the same measure. We could also figure out angles 3 and 4 because we know that's a straight line, and those two would have to add to 180. Now we have a theorem for angles formed outside a circle. So the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. So here are three pictures that are all the same situation. We have this angle 1 outside the circle. So we've got two lines going through a circle, but they're intersecting outside the circle. So we're going to take half the difference of the two arcs that were created by those two lines going through a circle, 1/2 x minus y. If we look at the second example, we see we have a secant and a tangent, but that still made two arcs, x and y, that we can subtract. This third example has two tangent lines. So x is half the circle, y is the remaining part of the circle. So there's three different situations you could see, but for all of them, we're looking at the angle outside the circle. Let's try an example. Finding inside angles. So can we find the measure of angle x? Well, it's an inside angle, so it's half the sum of the two intercepted arcs. So our first arc here is 46, second arc is 90. Let's take half of those added together, and we get 68. Angle 2, finding outside angles. So look at these two lines, they're intersecting outside the circle. So we want the difference of the two arcs. Now we see that this arc is 95. Do we know what this arc is? No, we don't. That's what we're trying to find. But what do we know? We know the outside angle is 20. So we can fill in our outside angle. We already know it. So 20 equals 1/2 95 minus z, the part we don't know. If we multiply both sides by 2 to cancel out that 1/2, we've got 40 equals 95 minus z, subtract 95, and we get z equals 55. We have a new theorem that will help us find, instead of angle measures, we can find segment lengths, segments in a circle theorem. So for a point P in a circle, the product of the lengths of the two segments from that point P to the edge of the circle is constant along any line through point P, through the point and the circle. What does that mean? Well, we're going to look again at three situations. So here I've got two lines intersecting inside my circle at point P. Here's my point P. If I go from that point P to the edge of the circle, I get a distance A. From P to the edge of the circle, I get a distance B. If I multiply those together, it's going to equal this other chord, which is going from P to the edge of the circle, a length of C, from P to the edge of the circle, a length of D. So we're always going from the point to the edge of the circle. So if I put letters on here to help us out, we can see that I'm going from P to J, line segment PJ, and from P to L, line segment PL, equals PK to PM. That helps us when we look at other situations. Now I've got a point outside the circle, but still my point P. I'm going from the point P to the edge of the circle. So I'm going to go from P to the first edge of the circle, which is this length W. But now I'm going from P to the other side of the circle. That length is W plus X, the whole thing. Same here with my red line. I'm going from P to the edge of the circle, that's Y. But from P to the other edge of the circle is all of it, Y plus C. We can see I'm going from P to O times P to N, and from P to Q times P to R. Let's look at a third situation. See, we've got a tangent and a secant. We're going from P, the first side of the circle is T, and P to the second side of the circle is also T, so we get this T squared. And then on the red line, we're going from P to the first side of the circle is Y, and from P to the second side of the circle is Y plus Z. So again, if we put in letters S, U, and V, you can see we're going P to U times P to V, and P to S times P to S. Let's try some examples. Find the length of chord Y. So we're missing this piece. But we know if we multiply the pieces together, they're equal to each other. So let's put in some letters for these points to help us out. Let's put in A, B, C, and D. So from P to A times P to B equals from P to C times P to D. So P to A is 6, and P to B is 6 plus 8. P to C is 7, and P to D is 7 plus Y. So let's multiply that out. We have 6 times 14 equals 49 plus 7Y. We get 84 equals 49 plus 7Y. Subtract that 49. We get 35 equals 7Y. Divide by 7. And that line segment Y equals 5. Let's find the length of segment Z. Again, we've got the tangent and the secant. So let's put in letters again, A, B, and C to help us out. So from P to the first side is point A. From P to the second side is also point A. So we've got PA times PA. And then we've got PB times PC. So we've got Z times C. And then we've got 8 times 8 plus 16. So we have Z squared equals 8 times 24. Z squared equals 192. Square root both sides. And to the nearest decimal, Z is approximately 13.9. So to summarize, when we're looking at angles, angles inside the circle are the sum of the intercepted arcs. Outside the circle, it's the difference of the intercepted arcs. With line segments, it's the distance from the point to the first point of intersection on the circle times the distance from the point to the second point of intersection on the circle. Good luck today.